Hello everybody, I am Shomita Mondal. I am a research scholar of the Civil Engineering Department of IIT Kharagpur, going to present you a web lecture series on the course Soil Mechanics. This is my very first lecture on the basic introduction to soil mechanics. Course will be helpful to various undergraduate students to understand various terminologies and definitions and concepts related to soil mechanics. This will be helpful for a civil engineer to get equipped with various knowledge that will help them to understand soil behavior and will eventually help them to deal with various problems related to soil in their various civil engineering projects in real life. So when we are talking about soil mechanics, the very first question that comes to our mind is what is soil? So soil basically for a civil engineer mean all naturally occurring unconsolidated earth material which may be both organic or inorganic, mainly a product of weathering of rocks that forms the outer crust of earth. Right. So a soil mass in its natural state consists of usually three phases. The basic ingredient is the soil grain, which forms the soil skeleton, and they have intermittent void spaces between them, which are filled with air or water or both. Thus, a soil in its natural state may be considered as a three-phase system. The different gravimetric or volumetric composition of these solid particles, water and air give rise to the different engineering properties of soil. So we will learn about this more as we go ahead in this lecture series. So talking about soil mechanics, we should also know that what is the importance of studying soil mechanics in civil engineering, right? So soil mechanics is basically the application of the principles of mechanics, hydraulics, and to smaller extent maybe chemistry to different engineering problems related to soil. Therefore, the study of the soil mechanics will be helpful to a civil engineer to understand the soil behavior and therefore will enforce its application as an engineering material. So basically it's a study of soil, right? So when we are talking about the applications of the soil as an engineering material, what we mean, right? So any structure, right, be it buildings, the skyscrapers, the dams, embankments, tunnels, highways, so which are either founded in or on the surface of the earth is built on soil, right? So these structures or the superstructures as we might say is usually built on a foundation. The foundation may be a shallow foundation or a deep foundation. We will know about it in the subsequent lectures in the series. So these structure transmit dead or live loads to this foundation, and the foundation ultimately transmits the load to the soil. So basically, my soil is the ultimate foundation material which supports the structure, right? So talking about the structures founded on the surface of the earth, suppose we think about pavements, right, or the roads. So be it rigid pavement, flexible pavement, the when a designer designs it, we are concerned about the what will be the thickness of the pavement, or what are the component part of the pavements. So the performance of this will definitely depend on the characteristics of the subsoil on which it rests, right? So the structure we are mainly building on the soil. The they are It's important to know that what will be the bearing capacity of the soil, what will be the pattern of stress distribution in the soil beneath the loaded area. So what will be the settlement of the structure or the foundation. We should also know the presence of the groundwater table in that area, which seriously affects the strength of the soil. So what are the type of the soil strata in the area, what are the shrinkage and swelling characteristics of the soil. So definitely the knowledge of the soil is important, the behavior of the soil is important, right? When we are talking about various structures founded in the surface of the soil, we think about underground structures, right? So underground structures like tunnels, conduits, or suppose we think about earth retaining structures. So the role of the soil is important here. Both the structure and the soil influences each other, right? So when the stability of the structure is itself affected by the soil behavior, the structure too causes stresses and strains in the soil. So definitely the analysis of forces acting on the structure is important, and also the aspect of stress distribution through the soil is also important, right? So when we want to apply the soil as an engineering material, we are concerned with solving different engineering problems. Different engineering problems, such as suppose we consider the effect of earthquakes or a nuclear explosions on the structure. So these are also greatly influenced by the soil medium through which these seismic waves travel, right? So the knowledge of the soil medium is important. The behavior of the soil under the earthquakes, the nuclear explosions is important, which will finally affect the structure. So in the those parts of the world, when the temperature is low, problems arise as soil expand upon freezing, and they exert a force on the structures in contact with them. So again, the knowledge of the soil behavior at those places where temperature falls below 0 degrees centigrade, it's important. Now when the ice melts, again the soil results in a loss of shear strength. So determining the strength of the soil is important. uh, Now suppose we are talking about earth dams, right? So soil itself is a construction material in the earth dam. Therefore the whole knowledge of soil mechanics is important while we are dealing with the soil as a construction material in the design of earth dams. So basically what we are trying to say, that soil mechanics is helping us to understand the behavior of the soils with respect to different engineering problems, and thus utilize it as a proper engineering material, right? Okay. So
So, when we are talking about soil, we should also get a brief idea about how soils are formed, or what, what is the origin of the soils. So, soils are basically the end products of the weathering of rocks. So when we talk about rocks, the rocks may be igneous type of rocks, it may be sedimentary type of rocks, or it may be metamorphic type of rocks. So these process of formation of soil is taking place continuously in nature, and what we say as the geological cycle, the soils are basically formed due to that. So this process mainly comprises of the process of weathering, decomposition and erosion, followed by transportation of these withered or eroded products to different locations by various agencies of transportation like wind, water, and finally they get deposited at places. These deposited particles or products may be again subjected to upheaval. This upheaval may be due to various forces acting on earth like large scale earth movements, or due to various flowing water or wind, and this upheaval process again leads to the process of erosion, withering, and thus a cycle goes on, and this breaking and withering of the rocks takes place, resulting in giving rise to unconsolidated materials or sediments, and that referred to as that of soils. So basically, if we try to look at a picture on classification of soils on the basis of their geological origin of the constituent sediments, soil is basically of two types. So on basis of geological origin of the constituent sediments, so one, the soil which are formed by mechanical disintegration, and the ones which are formed by chemical decomposition. And the next type of soil is the soils which are of organic origin. Right? So when we talk about the soils which are formed by mechanical disintegration or chemical decomposition, what is that? So we know that the parent rocks or the igneous rocks or the sedimentary rocks or the metamorphic rocks can be subjected to physical disintegration, and this is caused by various reasons, like at those places where the effects causes disintegration of the rock, like high temperature causes expansion of the rocks, resulting in exfoliation of the rock particles and gradually breaking them. Or suppose it may be the impact or the grinding action of the flowing water or wind that have a scouring action of the rocks that gets disintegrated and splitted into unconsolidated materials. Or suppose like we can talk about places where the temperature falls so low that this alternate freezing and thawing cycle induces stresses in the rocks which gradually disintegrates. Or maybe due to the action of plants that grows into the cracks and the fissures of the rocks and gradually splits them and disintegrates them. So gradually the rocks gets withered or eroded, right? By chemical decomposition mean that the soil basically are subjected to chemical actions or chemical decomposition due to oxidation or hydration or carbonation or leaching by organic acids and water, and actually gets into unconsolidated materials. Usually clay soils and to some extent silts are formed by chemical weathering. For mechanical weathering of rocks mainly give rise to soils which are coarse grained, for example gravels and sands. Another type of the soil which are not related with the disintegration of the rocks are basically the ones of organic origin, which are mainly formed due to the decomposition of plant and animal matter. Like in the forest areas, the type of the soils are usually of organic origin. Okay. So, as we were talking about the geological cycle, we see that this weathering and transportation of the soil affects the characteristics of the soil. So, by characteristics, we mean the size of the particles, the shape, the composition of the particles, the surface texture of the particle, the degree of sorting or the distribution of the particles in the soil. So, different soil accordingly will have different characteristics depending upon this the different agencies of transportation which are involved in the geological cycle, and accordingly carries the withered or eroded products to either different locations or maybe close to that of the parent rock too. So by different like suppose if water is the agency of transportation, so this effect of water causes rounding of the sand or the gravel particles of the soil, or suppose the action of gravity causes an angular or non-spherical soil particles. Talking of surface texture, what causes a very shiny and polished and smooth surface on the sand, while like the agency is ice or gravity, it causes striated surfaces on the soil particles, right? So these are the various effects of transportation. Moreover, the way the depositional environment that the soils are deposited or redeposited at a place, and the various geological events that takes place in the location also affects the properties of the soil. Like if we say the state of the soil, the soil, like the density, the moisture content of the soil, or the structure of the soil, like how the soils are stratified, or the bedding of the soil. So it will eventually affect the various engineering properties like the shear strength or the permeability of the soil. So we'll talk about it in details in later in this lecture series. Okay. So talking about soil, we can also classify or basically divide them into other groups, like we can call them to be a residual soil or to be a transported soil. So basically when the products of the weathering, the unconsolidated materials and soils are still located at the places where they are originated, that is, they are deposited at places near the parent rock, they are called as the residual type of soil. While any this rock particles or withered particles or the soil or the unconsolidated materials formed are transported far away from the place of the origin by the different agencies of transportation like wind and water or ice, and redeposited at thus at places. We call it a transported type of soil, right, or transported soil. So these transported soil can be further classified depending upon the transportation agency involved and the method of deposition. So first we can see what are alluvial deposits. So alluvial deposits are soils that have been deposited from the suspension in running water, right? So basically we can see these alluvial soils near floodplains, Like in India, we can large part of this soil remains in the Indo-Gangetic plains or the Brahmaputra flood plains, or to some parts of northern India lying north of the Vindhya Satpura range. So these soils are basically comprises of alternating layers of sand, silt, or and clay. Right. Next, we have what we say as the lacustrine soil. So these type of soils are ones which are deposited from suspension in still or fresh water of the lakes. We have marine deposits, which are the soils that have been from suspension in sea water. These type of soils are usually very soft and contains organic matter too. They are very low in shear strength and very high compressibility deposits. So what are shear strength, and we will learn about it as we go ahead in the series. We have what we call as the aeolian deposit. So aeolian deposits are the soils that have been transported by wind. We have glacial deposits, that are the deposits which are transported by ice. We have colluvial deposits, that is those soils which are formed by the movement of soil from its original place by the action of gravity, right? So for example, during landslides, the disintegrated or withered products of rock are transported to locations away from the parent rock. So colluvial deposits. So when we are talking about soil and soil mechanics, I must definitely add to it that whatever the concepts that we are going to study in this course, definitely consider soil to be isotropic and homogeneous. But in reality, this is definitely not the case. The soil deposits are far from homogeneous and being isotropic, and exhibit variation in properties not only from one location to another but also in the same location, strata after strata. Right? Moreover, we must also add that soil is a highly weighted material. Definitely a civil engineer must take into account the various factors that affect the behavior of the soil. He or she must keep in mind stress-strain relationship of the soil, which is highly non-linear and definitely varies from soil to soil. For example, the loose soil will have one kind of stress-strain relationship. The dense sand will have another stress-strain relationship, right? Moreover, the behavior of the soil is vastly influenced by the stress history of the soil, the depositional environment of the soil, the time, and the various geological events that occurs at the place. Moreover, like a civil engineer has to deal with a civil engineering project, the design definitely involves the determination of the various physical properties of the soil, right? He has to determine the index properties such as the specific gravity, the consistency of the soil, the particle size distribution, and various engineering properties like the permeability, the consolidation, the compaction characteristics of the soil. Sometimes he has to determine the optimum moisture content at which he would get the maximum density that he will obtain on compaction. We have to determine the consolidation characteristics of the soil, right? So accordingly we can judge the settlement of the structure that's happening, or accordingly we determine the bearing capacity of the soil, right? So the characteristics of the soil determination require tests, right? So we either do laboratory tests or we do field tests. So when we do laboratory tests, there is various disadvantage, and the major one is that when we collect samples, no sample will be undisturbed, right? So definitely whatever characteristics we are determining from the laboratory test may not reflect the likely behavior of the soil in the field, right? Moreover, when we are collecting samples from the field, we take a very limited number of samples, right? So there is, but my soil extent is huge, and the soil often varies from location to location and depths, right? So there is no guarantee that the soil parameter will represent the true characteristics in the field. Moreover, there is so much unexpected changes that takes place in the soil, so much environmental changes, like suppose the effect of earthquakes or vibrations can alter the state of a soil. Like for a sand deposit, vibrations alter them from loose to dense. Suppose we have a clay type of soil, which when in dry condition is extremely hard, but when the water content becomes high, it behaves like a liquid with little shear strength. So water is very also a very important factor when we control like when the behavior of the fine grain maybe. So like determination of the characteristics of the soil is important. There is various other factors that affect the soil, like the groundwater table in that area, or we consider that how the groundwater table fluctuate with environment and different seasonal variations take of it. So the seepage conditions, evaluation of the seepage conditions is very much important in designing of any project, right? So we it must be definitely added that definitely possessing the knowledge of the principles of soil mechanics is very much important to understand the soil behavior, and it will help our soil engineer to obtain the practical solutions. But definitely it's what will definitely require is proper engineering judgment, right? And this engineering judgment will only come through the experience and skill of the engineer when he can actually apply this theoretical knowledge into practice, right? Because theory and practical thing is very much different, right? So the performance of the soil in the design will definitely depend upon evaluating its characteristics very efficiently and judiciously, which would real task for a civil engineer based on laboratory test and field test, and that is only available to us, right? And because we have to also keep in mind the economy of the or our budget, right? So with the various constraints that is definitely available in real life, the geotechnical engineer will definitely apply the knowledge of the theoretical soil mechanics, and will, with proper reasoning and judgment, will deal with this highly variable soil and try to give satisfactory solutions while founding various civil engineering projects. So that's it for this lecture. Thank you.